Hi all. I want to talk about proportions, which are just parts of the whole, which involve fractions, decimals, and percentages. They can be told in any way. And first of all, I want to get the elephant in the room. Here's the elephant over here. The elephant's over here. Um, so when we first learned to count numbers, we learned 1, 2, 3, 4, 5, and then at some point an evil math teacher threw in fractions. And the only problem with fractions is not knowing fractions, because most people understand that. Here, let me change colors. Like if I say 1/4 of something, I mean that. Or if I say, 3/4, I'm breaking this up into quarters and I mean this amount. Or occasionally maybe you're splitting a pizza with two friends and that this is your 1/3. We're okay with quarters and halves and thirds usually because we use them a lot. So you have some sense of what those numbers mean. The problem is at some point we try to start adding those. And this is literally like adding apples. Like my apples is 2/3, and let me make this 2/3 over here. And my orange is 3/4. And to get to the answer of that, first of all, we can tell by looking at the picture, it's going to be bigger than 1, but those things don't fit together. So we have to convert them to something else. We essentially have to convert them to bananas before we can all add them together. And then we might have to convert back to strawberries for that to be meaningful. So addition of fractions is a really complicated process, but the idea of fractions should not be unusual. And the idea of proportion is just saying, well, instead of dividing up a pizza, maybe I'm dividing up $100, or maybe I'm dividing up 36 eggs, whatever it happens to be. There's something that I'm breaking it down to some smaller amount. And I can do this with larger amounts, but usually when we do proportions, it's a smaller amount. It's 2/3 or 3/4, something like that. But I want to, if you've ever had a bad experience with fractions, there's a reason for that. It's because it's very complicated. But the basic idea of a fraction is not complicated. Now, the other way we often express fractions is like most people know this up here is 0.75. I'm going to change colors again. They know this is 0.75 or 75%. There are 3 ways to write that number. This is also 3/4. Most people are familiar with that. But let's talk about how we get those numbers and what they are. So when we first started learning numbers, we probably learned the number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not exactly, but we got 0 down here. 2, 2, 3, 4, 5, 6, 7, 8. No, I was off by 1. 10. Okay, I think that's 10. And so 1, 2. So we were used to counting by numbers. And at some point, somebody decided to divide this part up down here. And they decided, oh, well, one way to divide it up instead of by quarters or by thirds is we could divide it up by 10. So I think I need 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, not quite perfect. But so if I grab I'm going to change colors again. If I grabbed this little amount down here, you'd know, oh, that is 0.1 or 1/10. You can write it either one. But we're used to counting by tens. In the same way, if I grabbed all of this amount, you might say, oh, that looks like he grabbed 0.7. It's useful. And we can get even smaller. I could get, if I could divide those things up by 10 even more, maybe I could say, well, this number out here is actually 0.89. We're relatively familiar with that because we're used to the 10-base system. And because we're used to that, instead of saying 0.89 or 0.7 or 0.1, sometimes instead we move the decimal over 2 places. I'm going to change the color again. We move the decimal over 2 places and we say, oh, well, that's 10%. Or if it was 0.89, we move the decimal over 2 places and say that's 89%. It's just a different way to say it. And when we're speaking, we don't usually say 0.89, but we can. We usually say, oh, well, it's 89%. And if you say 89%, most people will know you mean, oh, it's almost 90%. It's almost the whole thing. Little sliver has been shaved off. Maybe that was taxes. Okay, 10% is taxes in a lot of places. But those are the basic ideas, as there's different ways to express some partial amount. So here's where this becomes a problem, maybe. If I tell you I want to break this thing, let's say this represents $20. Okay, this is $20 here. I want to break this thing into 17 20/3. I want 17 20/3 of $20. I have no idea what that means. Okay, I do not use 20/3. If you told me 3/4 or 2/3, I'd have some sense of how much of the $20 I was going to get, or you were going to get, or whomever was going to get. But 17/23 is kind of meaningless to me. So mathematically, what we do if we're unfamiliar with this is we typically just take a calculator out, divide 17 divided by 23, and we are told, oh, that's 0.739, if my memory serves correctly, or about 74%. It's almost 3/4. And I know 3/4 of $20 is 15 because I just do that enough. We'll talk about how I'll do it exactly if I wasn't sure. But now I have a sense of, oh, I know roughly at least what fraction of this pile of money somebody's going to get. And I can tell you the exact amount if I had a calculator. So let's talk about the exact amount. I'm gonna clear everything here. All right. So once again, let's keep our $20. Okay, let's say this represents $20. If I ask you for 3/4 of $20, okay, maybe that's my portion of something that some job we did together. 3/4. I did more work, so I got 3/4. You get 3/4. One of us gets 3/4 of the $20. Most of you probably already know this is 15. But mathematically, there's a couple of ways to do it. And I just want you to conceptually, and then we'll talk about, well, now that we understand it conceptually, we can just do this in the calculator. So this is fourths. We're like, oh, okay, well, let me break this into 4 parts. Let's say that's 4 equal parts. I need to take 3 of those parts. That is what 3/4 is. And I happen to know that 4th of 20 is 5. Okay. So that's $15. Okay. 15 is how much somebody gets if they're owed 3/4. Now, mathematically in the calculator, and this is important because if this number is not 3/4, but something like 17/23, which we'll do in a second, the process doesn't change. But conceptually, you need to understand this, and then you can understand what's going on in the calculator. So what we just did is we took 20. Now, this is weird. We're dividing it by 4, and we are multiplying it by 3. That is what we did. Okay. That's what 3/4 of 20 means. Now, some of your teachers will tell you, well, that of means times. Anytime you see one of these problems, 3/4 of 20, 75% of 20, that means times. And it kind of does. Okay. So that is the other way you could have done it. You could have done 3 divided by 4. That would give you the 0.75 in your calculator. And then you could multiply it by 20. Notice my operators are still the same. I can't randomly do them in there, but I've got to have a divide. I've got to have a multiply. So 0.75 times 20 in my calculator also gives me 15. So this doesn't change. I'll just point out, there is one other way to do this. It's weird. It would have also been okay for me to do 20 times the 3. 3's up in the top. Those are together. This is like over 1. And then divide it by 4. Mathematically, it will give me the same number, but that seems a little weird. It looks a little bit like I'm multiplying by 3/4 over here. I am. But depending on your calculator, that actually will work fine. But really what I'm kind of doing is that. All right, all those will work in your calculator. So if we change this to 17/23, so first of all, I can convert 17/23 to the 0.739 that I just found out it was, but I don't have to. I can just, replace this 20, divide it into 23 parts, and then multiply it by 17, and that will give me the answer. It's going to be almost the same number because this is just a little bit less than that. So it's probably like $14. Okay, very close. You can check it out yourself. But that's the idea. Anytime you see 3/4 of something or 75% of something, or you have a pile of money, you're owed 75%, generally you're going to multiply the larger number times the fraction. That's not 100% true, but it tends to be true. There's one other kind of problem you can get, which is this thing, but backwards. Okay. So if we do it backwards, this is what it looks like. I'm going to clear everything here. Let's say for some reason, let's see. Let's say something costs $15 and you're going to resell it, and you always want to resell it for whatever the price is. 3/4 of that price needs to be how much you paid for it. So you went out and bought something, you paid this amount, basically whatever you're selling it for, 3/4 of that sales price needs to be 15. because you need to cover your costs. And then that extra 1/4 is what you made. It's not the only one. So this is the same problem, except look, this is where you have to decipher it. Oh, they gave me this. I'm trying to find the number that generated 15 when I took 3/4 of it. So I'm trying to find this number. So you could guess and check, that would work. But this over here, we know what this number is already. So 3/4 times something gives me 15. So this is exactly like if I had 10 equals 2x. So this is a little basic algebra. Like, well, wait a second. I just divide both sides by 10, 2, and it's 5. Same thing here. 3/4 of this equals something. That's my x. That's a times. This is my x. So if I divide out my 3/4, it will give me the number in the same way down here. I get x equals 5. So over here, I'm going to divide by 3/4. This will totally work. You can divide by 3/4. You can divide by 0.75 because that's all that is. Okay. I want you to understand mathematically, there's one other way you can do this. Okay. And you have to be a little careful when you're dividing by 3/4. You might want to turn it into 0.75 first. You won't have a problem. But the other way to do this mathematically, and some of you know this, when you divide by a fraction, it's the same as multiplying by a reciprocal. Okay, so I'm going to do one more thing. I'm going to clear this one more time. So when I do 15 divided by 3/4, in my calculator, there is no difference than me doing that than me doing 15 times 4/3. You're going to get the same number. It's weird that it works out that way, but it is. So in my calculator, I can do 15 divided by 3 divided by 4. That's a little dangerous. Really, I'm dividing by 0.75. This double division, depending on your calculator, is a problem. Or I won't make a mistake if I do this. 15 times 4 divided by 3 will work. All right, let's see. Anything else I need? No, and the only difference is if I give you a weird fraction, once again, if I happen to say you started with 15, something costs $15, you know that the list price needs to be, your cost needs to be 3/4 of the list price. You're trying to figure out the list price. I know the list price needs to be more. I know that whatever I'm looking for has got to be bigger than 15. So I'm going to divide by this number that's less than 1. It will give me a larger number. If I mess that up, I need you to just think, oh, I know I was looking for a larger number. I must have typed something wrong in my calculator. I got something flipped upside down. I typed in something wrong. But if I happen to say, well, our ratios have changed, it's 17/23, it doesn't change the problem. It just means I don't really have a sense of what this is. I could figure out what that was first, so I'd have a better sense. But the main thing is, you need to know how to take a percent of something else. That's the most important. You shouldn't be thrown off by some weird fraction. And the easiest way to deal with it, if you're thrown off by some weird fraction, is to convert that fraction to a decimal, which is just by dividing, or turn it to a percentage, which is dividing and then rotating the decimal over 2 places. Okay, that was take 2, and it was a little bit shorter, although I'm sure to you it felt long. See ya. Oh, there's a bunch of problems you're supposed to do now.